Gracious Heavenly Father, we are so thankful that how you protected us in the midst of the COVID-19, that you have given a medical field to enhance our health. And Lord, as Katie leads out and discuss about vaccination, I pray that the information that we hear and to learn so that we can better understand, so we can share that good information with others. And thank you for the leadership of Sue, of having this meeting. And I pray that you be with all of us as we participate. In your precious name of Jesus Christ, we pray. Amen.
Okay, well, hi everyone. Good to see everybody. By popular request from my Sabbath school class, I mentioned to them that I have a neighbor who is a pharmacy PhD, and I asked them if they would like Katie to come and talk to us, and they were very enthusiastic about it. So Katie was very gracious to agree to do this. And you know, Chuck and I were always very impressed with Katie, and then we got her resume for this little talk, and then we were like amazed that she would even associate with us. Katie's been the director of marketing for Lipitor. She's managed over 300 people. She's worked for companies like Park Davis, which is a division of Warner Lambert. She has worked as a pharmacist. She's been at many speaking events, including those where Anthony Fauci has been. She's an adjunct professor at one of the top pharmaceutical schools in the country, which is Purdue in Indiana. And she's just an all-around great neighbor and friend. So I'm grateful that Katie is going to be giving us some information on the coronavirus, the COVID-19, and its vaccines. I'm going to ask if you have questions of Katie. She's going to make a presentation first, and then she's going to have a question and answer session afterwards. So if you wouldn't mind, either type your questions into the chat if you are afraid you'll forget them, or hold them to the end, and then Katie will be able to answer the questions at the end of the chat. So Katie, thanks so much for taking this time out to do this for us. We appreciate it. And I'll turn it over to you now. And I am recording, by the way.
Okay, that sounds great. So I'm going to share my screen. Let's first make sure that works. Fantastic. Okay, so I will give one small disclaimer, and that is that I am not a COVID scientist or an expert on COVID vaccines themselves, but pretty much what I do and what my training is to analyze and evaluate data and scientific information and communicate it to people, whether that is the public or some of the companies I do work for. We talk to investors and things like that. So I will tell you the source of everything that I present to you today, because I'm very conscious of making sure that what I'm communicating is quality information. And I will try and give you some hints on how to make sure the information you're receiving is quality. Because I think, as we all know, there's a lot out there about COVID and the vaccines. Okay, with that being said, my goal for today is to talk a little bit about how these vaccines work. That was one of the questions Sue had for me, is understanding how these vaccines actually work to protect us. Who have they been studied in? We've all heard some of the data. How effective are they? How safe are they? And then really, why should you get vaccinated? You know, because I think a lot of people, you know, may think, well, I haven't known anybody who's gotten very sick. And so why should we get vaccinated? So I'll go through that as well. Okay. So before I get too far, and I will pause and take questions as I go a little bit as well. So a little vocabulary lesson, just so that we're all on the same page. So I think it's important to understand that coronaviruses are actually a family of. So the current coronavirus pandemic is not such a new thing for us. We've had coronaviruses before. Coronaviruses are a family of viruses, and they like to attack the respiratory system, your lungs, and the gastrointestinal tract or your GI tract. And so you may have heard of SARS and MERS. These were coronaviruses identified in the early 2000s that caused some epidemics, one in China, one in the Middle East. And by the way, there is an international body that names these viruses, believe it or not. So they get names and numbers and everything. One little known fact is that the virus that we've all had many, many times that causes the common cold, and there's several of them, those are a coronavirus, right? So when you get a cold in the middle of winter and you get a runny nose and you get what you think is bronchitis, maybe you get inflammation in your lungs and you're coughing and wheezing, that's a coronavirus. It just so happens that the common cold ones that we've had have not proven so deadly or so serious as this current coronavirus, which has been lovingly named the SARS-CoV-2 virus, okay? And SARS, all that stands for is severe acute respiratory syndrome, right? So it's very general. If they have one of these coronaviruses that causes a respiratory syndrome, it's going to now get called a SARS virus. And then CoV is for coronavirus. And then 2, this is because it's the second big one they've identified. The first one was the one from the Chinese epidemic in the 2000s. And now this new one is from 2019. So, this was first identified in Wuhan, China in 2019. And this virus, SARS-CoV-2, or the coronavirus, is what is causing the disease, which is COVID-19. All right, so that's the nickname that's been given to the actual infection that people get. So SARS-CoV-2 is the virus, and we'll commonly call it the coronavirus because that's just easy. And COVID-19 is the disease, okay? All right, so let's talk a little bit about these vaccines. And probably everybody in one way, shape, or form has seen this photo of the coronavirus molecule. And this is, it's a 3D animated picture based on the chemical makeup of the coronavirus. And the most important part of the virus for vaccines is what's called the spike protein. And these are these little red things that you see sticking out of the coronavirus. And without the spike protein, the virus can't get in your cells. So the spike protein is how it gets in. That's how it infects you. And so that's what the virus uses to get in and infect your cells. Now, what's really clever about these very new vaccines we have, the first 2 vaccines, is they're actually using the spike protein against the coronavirus. They're basically taking a chunk of that coronavirus and turning it against the virus itself. And I'll show you how that works. Okay, so I'm not going to talk about every kind of vaccine today, but be aware the 2 vaccines that you've all heard of, the Moderna vaccine and the Pfizer vaccine, right, that we all hear about in the news. These belong in this what's called nucleic acid family of vaccines, and they're mRNA vaccines. I'll explain what that is. There are other vaccines in development, some of which are also that kind of vaccine. There are some vaccines that are actually using the virus itself. It's a killed virus. There are viral vectors. There are protein-based. And as those come down the pike, they're going to work a little differently. But essentially, the big thing about all of these, a really important thing to remember, is even the vaccines that will use the virus itself to turn on your immune system, they're not using the live virus. You cannot get sick. You cannot get the coronavirus from the vaccine. So when you get your flu shot every year, does everybody get a flu shot? I hope. If you get a flu shot, you're actually getting flu virus, but it's been killed. It's been deactivated. And so what they're giving you is flu virus. Okay, so back to the coronavirus. So let me show you how this works. And it's kind of a crazy slide. But basically what's in the vaccine itself is only the spike protein. Okay, oops. Oh, here we go. Is only the spike protein. And it's actually not even the whole spike protein. It's like a little component of it. It's part of the DNA of the spike protein, right? So what they do is they take what's called messenger RNA or mRNA. So when you read about these vaccines, you'll hear them called mRNA vaccines. All that is, messenger RNA is a copy of the DNA for the spike protein. So you see this little wavy thing here in the diagram, that represents the RNA. And what the mRNA is one piece of that, and that's what makes copies. So once mRNA gets into a cell, the cell takes the mRNA, it's like a photocopier, right? And it just keeps making copies, copies, copies. And that's how the infection works, right? Well, what these clever scientists did is they were actually able to take the coronavirus, they're able to isolate those spike proteins, and then they're able to actually extract this genetic piece, the RNA, out of the virus itself. So all that's in the vaccine is this RNA. Okay. What they do then is they enclose it in what's called a lipid nanoparticle. And you may have heard about these lipid nanoparticles in articles. All these are is really, really tiny little bubbles of fat. Okay, lipid is fat. And the reason they use that as the transporter, and it's really just like the package. It's like the Amazon box, right, that this stuff is in for delivery. And the reason they use that is things that are fatty or a lipid can get across cell walls very efficiently. So that's why they do that. Just to be clear, there's no microchip in the nanoparticle. The government is not inserting microchips into us with the vaccine, okay? So the vaccine has these mRNA bits in the nanoparticle, and this is a little injection, and that goes into your cells. So your cell takes it up. Now, here's where these vaccines are really pretty cool. They're using your body as a little manufacturing plant. So rather than gathering up lots of virus like they do with the flu vaccine, and then they kill all the virus and they give you a whole bunch of virus, what they're doing is giving you a little piece of the code for that spike protein, and your body is now replicating that code. So your body becomes the little manufacturing plant for that messenger RNA. It gets put into proteins and goes out into your cells, and your cells go, whoa, that's not something we recognize. And so your body makes white blood cells that are going to fight that spike protein. So what this vaccine is doing is causing your body to manufacture antibodies, right, against the spike protein. And if you can inactivate that spike protein, it can't infect you. So the idea is you get the vaccine, your body revs up, it makes a lot of this spike protein, and then your body goes, whoa, and it makes antibodies to the spike protein. So now if you go out in the community and somebody were to sneeze on you who has coronavirus, and the coronavirus and its spike protein came in your body will send antibodies and say, bam, I'm going to destroy this coronavirus and you can't get infected. Okay, that's the idea behind these vaccines. So once you have antibodies in your system, if you get exposed, your antibodies attack that spike protein, and without the spike protein, the coronavirus cannot infect you. Okay? All right, so let's talk a little bit about the studies, because boy, there has been a lot in the news about the studies. So first, what I want to say is all the information I'm going to share with you today is from what's considered the gold standard for truth in science, which is a peer-reviewed publication, right? So we see things, you know, a press release gets put out by the scientists or by the company, and then a news organization picks that up and reads the press release. What you're getting there is very select snippets, right? What happens when something is a peer-reviewed publication, and both of these vaccines, the Pfizer vaccine and the Moderna vaccine, have had their data published in the New England Journal of Medicine. So the New England Journal of Medicine for the entire world is the top publication, okay, a peer-reviewed publication. And when the scientists submit this information, they have to submit the paper, they have to submit the original data, and then the New England Journal of Medicine sends it out to other scientists and they say, we want you to review this. This is the peer review. And so basically what they're really trying to do is sniff out any sort of BS, right? They want to make sure that the data is being represented accurately. So what I'm going to share with you today is what has been published, one in late December and one in January for each of these vaccines. Now, it's important to know these publications are kind of interim because these studies are still going on. So this data is early yet, right? We just finished the studies. People are still being watched who got the vaccine or who got placebo to see how effective the vaccine is in the long term. The other thing they're doing is they're now enrolling younger people down to age 12. They're looking at the efficacy over a longer time and they're monitoring the safety. So these people, they get seen, they get phone calls, and they're watched for a long time. Okay. So this is a quick overview. And as I've done this, I've got the Pfizer on the left, Moderna on the right for everything I'm showing you. So interestingly, both studies started on July 27th of last year. Pfizer finished in November and Moderna finished in October. Now, when I say finished, that just means how many people had enough vaccine on board. They wanted people to be at least 1 week out from the second shot, okay? And I have to say, this is supposed to be 28 days. Oh, sorry, 28 days apart. That's a little bit of a mistake. I apologize. For the Moderna study. Okay, so the one thing you're going to notice about both studies, they studied a lot of people. These are very, very big studies, much larger than studies that are normally done to approve drugs. So these are very big studies. And the Pfizer study had almost over 40,000 people. The Moderna study, 30,000 people. And generally what happens is half the people get vaccine and half get placebo. Now it's not exactly equal, but it's very, very close, okay? Both of these vaccines are 2 doses. The Pfizer vaccine is 21 days apart. The Moderna, it's 28 days apart. So when you hear people say, well, when am I going to need my second dose of vaccine? The recommendation is always going to be for you to get your dose of vaccine as close to how they studied it as possible, right? Because that's what we know. Everything else is kind of the unknown. But it's not going to be a disaster if you're not on day 21 or day 28. And lots of people will probably get their second dose of vaccine at day 35 or maybe day 20. It's not going to be the end of the world, okay? The study populations, these are very wide age ranges, 16 to 91, 18 to 95. The groups were almost half and half, men and women. And the race and ethnicity is close-ish to the US population, a little light on Black or African-American. I think the Black or African-American population in the US is around 13%, and these vaccine studies had about 9 and 10%. So a little under what we'd love to see, right? Everybody else is pretty closely represented to how they make up the population. And about a little under a third of the patients were Hispanic. And these studies did include patients who were obese because that's a group that has been identified as being at risk for coronavirus. Okay, so let's talk about this. So in general, these have been highly inclusive populations. So one of the problems with normal drug development is we tend to study drugs in very narrow populations because we want to make sure what we're seeing is real. These studies were so big that they were able to be very general with the population, which is good because that comes close to mimicking how it's going to be in the real world. So pretty much, and currently they are studying people over age 12. So men and women, age 12 and up. Originally, the studies cut off age at 85, but people over age 85 snuck in there. So there are people into the 90s that have been studied. And people had to be generally healthy or have stable chronic conditions. So the studies do include people with diabetes, cardiac disease, liver disease, chronic lung disease, HIV, severe obesity. So these are very inclusive studies. They did not exclude a lot of people. Now, they did exclude some. So who have we not studied, right? And these groups of people, it's going to be tough for them to decide whether or not to get the vaccine. So pregnant women were not included in the studies. Now, some women did get pregnant during the studies, and they're following them just to see how they respond and the safety of the product. People who are immunocompromised. So if somebody had cancer, was undergoing treatment for cancer, maybe somebody with something like lupus or a severe immune disease, people on high doses of steroids. There are some rare bleeding conditions that couldn't participate because they couldn't do the injection for fear of bleeding. And then anybody who'd been previously infected with this virus. So these people are probably not, for the most part, going to take the vaccine, which is one of the reasons it's going to be important for the rest of us to get vaccinated, because these folks are going to hang out and not be protected. So the more of us that get vaccinated, the more protected they will be. Okay. Now, I know this is tiny and I may have to blow it up, but I don't want you to have to memorize numbers. What I do want to show you, so this is the Pfizer study. These are the results. And this is the efficacy overall and by subgroup, which is why I pulled this. And this is after 2 doses. It's 7 days after 2 doses. So it's not very long. Now, they have reported out in the public domain that the efficacy seems to be holding, but we haven't seen it in a peer-reviewed setting yet. So that's kind of to come, that we'll see how the efficacy looks over time. But what we see so far, you keep hearing 95% effective. What they do, so if we look overall at everybody, and we look at the people who got the vaccine, the active vaccine, there were 8 cases of people that got sick out of 2,200 people, okay? Or I'm sorry, surveillance time, at an average of 2.2 months. So 17,000 people had at least 2 months of vaccine exposure under their belt. The people who got placebo, 162 of them got exposed. So what they do to get the 95% is they do a little fancy math, right? They do 8 cases over 17,000 people. They do 162 cases over 17,000 people. And then that difference is the 95%. So really what this means is that if you get vaccinated with that Pfizer vaccine, you're 95% less likely to become infected than somebody who doesn't get the vaccine. That's what 95% effective means, right? It's always comparing the person who got the drug to somebody who didn't get the drug, okay? Now, what we see is that this 95% effectiveness, it holds up over age group. And in fact, the older folks do a little bit better. The people over 75 in particular had 100, nobody got, the vaccine efficacy is 100% because nobody got sick. Between men and women, it's pretty equal. The men did a little better. And then by race, again, the African-American population did the best. The 100% effectiveness, nobody got infected, but everybody pretty high. This is a tiny number of all others, so you really can't get too excited about that. The Moderna vaccine, same thing. So you're seeing here, all patients across everybody, 11 people on drug, 185 on placebo got infected, 94% effective. And all the numbers look pretty much the same in the Moderna vaccine. So the summary of this is, as vaccines go, these vaccines appear to be highly, highly effective. When they started these studies, the FDA said, look, we needed you to be at least 50% effective. We'll approve you if you're 50% effective. That was what they are hoping for in the long term. The fact that these are like 95% was a huge surprise to everyone and very exciting. Now, it's early, right? And it's probably going to come down a little over time. We don't know how far down. That's, you know, a stay tuned kind of thing. But so far, so good. These vaccines, and this is really pretty new technology, is pretty exciting because it seems to be very effective. Okay. Now, whenever something's highly effective, my antenna go up, because sometimes that means it's also going to be really toxic and it's going to have a lot of side effects and problems. So again, I apologize for the teeny tiny print, but I'll send Sue the slides if you want them. what they looked at is two things in each study. So this is the Pfizer study, and the adverse events are down here. So this first one I'll show you is pain at the injection site, which seems obvious, but now what you're seeing here, mild is green, moderate is blue, and severe is orange. So most of the reactions were mild. So this is people who were less than 55 at their first dose and their second dose. And you'll see the people that got the vaccine, they were about 66% of them reported pain at the injection site. Most of it was mild, a little bit of moderate pain, very little severe. Your placebo people also reported that. This is in the older people over 55. People under 55 apparently are wimps because more of them reported pain. But again, most of it was mild. Redness is the second one. You can see very little redness overall, 5%, and a little bit of swelling. And I think we've all heard that from people who've had the vaccine. Oh, I had a little pain, some redness, some swelling. And you can see from dose 1 to dose 2, the numbers go up a tiny bit, but not much. So, hopefully we're not going to see big differences between dose 1 and dose 2. All right, so those are the immediate things. The things happen when you get the shot, right? Now, what happens over time? So these are all other side effects: fever, fatigue, headache, chills, vomiting, diarrhea, muscle pain, joint pain, and use of something like Tylenol to bring a fever down, okay? Now, the interesting thing about these, if you look, you really need to always compare the drug to the placebo. And this is one good example of how strong the placebo effect is. People, who got nothing but a shot of saline, if you look, reported fatigue, some of them, right? Now, they didn't get the vaccine. So I always look at the difference because, our minds are really a very, very powerful thing. And if you think you got a vaccine and you've read an informed consent that said the vaccine might cause fatigue, you might report fatigue. But there is a difference, right? So the people who got the vaccine were more likely very low amounts of fever, right? And the fever seems to be happening at the second dose, not at the first dose. So somewhere between maybe 11 and 16% of people got a little fever. It's mild. The green is mild. Fatigue, same thing. You want to look at the difference. So this looks like about 40%, about 36% of people with fatigue. At dose 2. The other one that kind of pops here is muscle pain, but you've got very, very low numbers for things like vomiting or diarrhea that would be more, kind of severe reactions, and most of them were mild. So, I think the summary of this, and let me show you from Moderna, it looks the same. Okay, so the Moderna, you're seeing, this is placebo, dose 1, placebo, dose 2, and then vaccine dose 1, vaccine dose 2. So the gray bars are grade 1, and that's like a mild. Grade 2 is kind of moderate. Grade 3 would be severe. And so, again, looking at the local events, right? Pain, this is redness. Erythema just means redness. Swelling. Lymphadenopathy just means you've got kind of swollen lymph glands, right? So most of it's very mild. The people who got the vaccine had a higher rate than the people that got placebo, but the placebo is not 0. Pain was the big one. And then all the other ones are really very low. It looks like about less than 10 or 15% for those things. So again, I think we can all expect if we get a vaccine, there's maybe a 10, 15% chance that we're going to have maybe some redness and swelling. We might feel some pain. It looks like, a good number of people reported pain. But the pain is mild. That's what the gray bar is. And then again, with things like fever and headache and fatigue, myalgia is just muscle pain. Arthralgia is joint pain. These things, happened a little bit more with the vaccine than the placebo, but you can see in some cases, the placebo people report almost as much as the vaccine people. And when you think about headache, a lot of us get headaches all the time, right? So it's kind of hard to discern. But generally, I think people can expect when they get the vaccine, they may have a little redness and soreness the day they get the vaccine. And then in the short run, they might feel a little funny, right? A little fever, a little headache. A lot of people will tell you That's because your immune system is doing its work, right? It's making those antibodies. And when your immune system is busy making antibodies, some people will get a fever and achiness and they feel kind of crummy, like they're getting sick. So it's really not a sign of anything bad or anything going wrong. And in some cases, people think it's a sign that you're having a really good response to the vaccine. So we're just going to put up with a little discomfort. Okay, so the last thing I want to just go over is why get vaccinated? Why do this, right? And I do not want to scare anyone, but I think we need to be aware. So I think, as we all know, COVID-19 can be deadly, right? And especially in people over age 65. Now, what's interesting, if we look, and this is death rate, this isn't just, I don't feel good. This is people who actually passed away. You can see the death rate goes way up over age 60, right? And then you get to age 70 and particularly age 80 plus, this is a pretty, can be a pretty deadly disease. And if we want to compare it, if you're age 65 to 74, you would be 4 times more likely to die of COVID than an accident, like a car accident, right? 3 times more likely to die of COVID than diabetes. So for older people, we really need to take this very seriously. Younger people who get sick are actually much less likely to die from COVID than something else. They're more likely to die from an accident or suicide or homicide. So younger people generally are not likely to die from COVID, right? That tends to be older people. However, we're finding more out about this all the time. This is still emerging information, but the COVID-19 infection can have some pretty nasty long-term effects. So most people, thank goodness, who get infected and have symptoms recover completely within a few weeks, no problem. But there are some people, and we don't have good numbers on this yet, but even people who've had only mild symptoms, that they get these lingering symptoms, and you may have heard them called long haulers. So there are long hauler groups and people who've been sick. We're still only about a year into this epidemic, this pandemic, so we don't know that much. But what we do know is that people are having very long-term lingering symptoms, some of which are quite serious. So some, fatigueness, shortness of breath, cough, joint pain, chest pain, muscle pain, headache, all the things that are just uncomfortable and you just still feel sick, even though you're sort of past the window of infection. Loss of smell or taste. Some people report problems with their memory or concentration, sleep problems, skin things like rash or hair loss. So if there's a good reason that we want to protect people, is because I think we want to prevent these longer term problems that don't seem to be going away in these long haulers. And I think none of us wants to have this happen. Much more serious is organ damage. Again, this is still emerging, but the lungs in particular, and some of this information was reported just this week, are showing that they can develop scar tissue and you can have long-term breathing problems. And this is just a really very interesting graphic that was on the news showing x-rays. This is from the University of Texas. And you can see this is what a normal lung looks like on an x-ray, nice and clear, right? So the areas where it's black is air. And that's what you want, right? You want your lungs full of air. If you look at a smoker's lung, right? Somebody who's been a long-term smoker, you can see how cloudy it looks. And it's because their lungs don't hold as much air, right? There's problems. Now look at somebody who's had COVID-19 and their lung is just full of scar tissue, inflammation. This is why you hear people say they can't get air. And so this is probably one of the most serious and sort of frightening long-term problems. They've also detected problems with heart, muscle damage to the heart, damage to the brain, like strokes and seizures. They think this could increase risk of Parkinson's and Alzheimer's. So, I think a lot of people aren't worried about dying from COVID, and that's fine. I think we don't want to live our lives scared. But if there's something that frightens me, it's more this stuff, because I don't want to have to live, long term with these effects. And this is what probably convinces me to behave myself and wear a mask and go get a vaccine as soon as I can. Probably the best reason to get vaccinated is really what it does for everybody around us, right? And it's really Some people consider it a responsibility. Some people consider it a gesture of love and courtesy. But if you've ever heard of herd immunity, this is what we're trying to do in the United States. And the best way to do it is through a vaccine. It's not through letting a whole bunch of people get sick. Okay. So when we don't have herd immunity, what happens is you've got all these people in red who might be infected, right? And these people here who are sort of little blue people are susceptible. They could get infected. And so stuff spreads like wildfire. And that's kind of what we have going right now, right? And what happens is it overwhelms the hospitals. People get sick, they go to the hospital. People that need other care in the hospital can't get in. They're running out of beds. The medical community is just exhausted. So that's a problem. So the great thing is once we vaccinate people, so the little people in green who are immune because they've been vaccinated, okay, they can't infect anybody else. So now your little vector of this infected person, they've only got these susceptible people to go for. And let's think about who these susceptible people might be. We talked about them before. It might be a pregnant woman. It might be a little child who's 3 years old. It might be somebody who's got cancer who can't get vaccinated. So, you know, all of us that can get vaccinated and become these little green people, that will help protect everybody else so that we won't infect one another. And that's really the goal that they're shooting for. Okay, one last bit of information. And again, I'm not an expert on the dissemination of the vaccine and where to get it and everything else. I'm reading as much as anybody else. But I did find a really nice piece of information from the Federal Trade Commission. So one thing to be aware of, the vaccine should be free for all of us. The government has paid for the vaccine to be administered to every American, okay? Now, that's during the pandemic. We don't know what will happen really long term. So again, another reason to get vaccinated as soon as you're eligible and as soon as you can, there's a supply for you, is that it'll be free. If you wait too long, you might get into a point in time where you're gonna have to pay for the vaccine. So it'll be free as long as the pandemic is ongoing. And it doesn't matter whether you have insurance, if you don't have insurance, if you have Medicare, Medicaid, everybody should get the vaccine for free. The one little footnote to that, right now, there's nothing in the law that says that undocumented immigrants shouldn't get the vaccine. They should be eligible for free vaccine. But there's been some controversy about this. There are some states where the governors have put in place policies that seem to discriminate against undocumented immigrants. So that one is a little bit of a footnote. I think we'll hear more about that as the vaccine becomes more available, but everybody should pretty much be able to get a vaccine. And as usual with anything that happens, there's somebody out there looking to make a buck. And the Federal Trade Commission has detected some scammers and vaccine scams. So just to be on the lookout, you should not have to pay anybody to put your name on a list to get the vaccine. You can't pay to get early access. You can't skip in line. There's no fast pass like at Disney for the vaccine. We all have to wait our turn. And nobody should call you and ask for your social security number or things like that for you to get the vaccine. So all those things should be red flags. You should ignore them or you can report them. But just be aware that we all should be able to get the vaccine for free, okay? And that's everything I had today. So I don't know if anybody has any questions.
I'm going to ask the first question, one question, and then I'm going to try to figure out a way to, because I know we have limited time. Katie, I'm going to display my ignorance here, but is there any way this new way of developing vaccines can re-engineer our personal RNA or DNA?
So that's a good question, Sue. And again, I am not a super expert on that. I will tell you this mRNA technology is part of what has been studied for some of the very specific cancer treatments that are out there. So the same technology is being used where instead of looking at the mRNA of the spike protein, they're actually looking at the mRNA of the cancer. So for certain cancers that used to be highly incurable, They're currently doing things like they will isolate the DNA from the cancer and turn on your body's immune system to fight the cancer that way. So instead of giving you chemotherapy, they teach your body how to attack the cancer. So that is happening now already. And what will be interesting is to see what in the future, what else they figure out to do with this technology. But it's absolutely applicable to other diseases.
But will it affect personal DNA or my RNA or DNA?
Oh, I see. Yeah, no, it will not alter your RNA or DNA, but one bit. So what happens, that nanoparticle that goes into your body, right? That little lipid nanoparticle that carries the spike protein. Once that spike protein is replicated by your body, two things happen. Your body absorbs that nanoparticle and eliminates it. It's a little teeny tiny thing. That spike protein mRNA now that your body made, and your body makes antibodies against it, your body then gets rid of it. It attacks it and gets rid of it. And then it's
okay.
So this is kind of like a self-disposal system. And that's why the technology is so great. We're using our own bodies like a little manufacturing facility, but then our own bodies are also kind of the garbage men, right? It gets rid of everything as well. So it's a really, that's I think why these vaccines are actually very, very safe. Is because of the technology.
June, do you have a question? And do you have a question, June, that you'd like to ask? You're on mute. June, you're on mute. And Salu, I'm going to ask you next.
Hailu, did you mean Hailu?
Well, Hailu, do you have a question?
Yes.
Go ahead.
Okay, two questions. One is why is the vaccine being given in 2 doses? And the second question is, once you get the first dose, before you get the second dose, can you be, is the vaccine still effective until you get the second dose?
Great question. So the reason the vaccine is being given in 2 doses is because that's how it was studied. So that's, they always give things the way that they've studied them and they know the most. However, they do have data after just 1 dose, that in between time. And it does appear the vaccine is pretty effective even after 1 dose. What we don't know with these vaccines, right? So they've got the 1 dose and then you're supposed to get your second dose at say day 21 or day 28, right? These studies are never perfect. People have schedules, people miss doses. So some people have gone a lot longer before they got their second dose. And they actually have shown that effectiveness, the 95% effectiveness, it's not quite that high, but it's still pretty good, even after 1 dose. What we don't know is beyond having that second dose at maybe 35 or 40 days, what happens. Now, the reason 2 doses, and this is true with lots of vaccines. So you get that first dose, your body starts revving up, you make antibodies. Some people, your immune system is so good, you make the antibodies so fast that they kill all that spike protein off, and you don't have enough antibodies to protect you if you get an infection, if you get exposed to somebody who's infected. So they give the second dose, it's a booster, right? Remember when you were a kid and you got vaccines and you needed a booster? That's what the second dose is. It's a booster. They give you more spike protein. Now your body goes, whoa, I got to make more antibodies. And you make more antibodies. So it's just to bump your antibody level up. There is another vaccine in development from Johnson & Johnson that is a single dose. So we will probably see at least 1, if not more, single dose vaccines come along. And some of them are using a little different technology. Sometimes it's just the dosing. The problem is this, because we've done this so fast, they didn't have time to do a study to say, well, we'll just give one group 1 dose and another group 2 doses and see what happens, right? They couldn't take that risk because this is a pandemic. So they went ahead and did 2 doses. So way in the future, we may learn a little bit more about if you only get 1 dose. But right now, the recommendation is 2 doses because that's what we know.
Okay, we have a question from
you.
Gannett. She wants to know if it has MRC5 in it. And I heard Hailu say thank you.
Yes, okay. It does not. It does not contain that preservative. And that's one of the cool things about this nanoparticle that you've heard about, that's the delivery system, because we have lipids all throughout our body, and that's just a little lipid nanoparticle. So it's nothing strange or foreign to the body that's being used to deliver this. There's actually no preservative at all in this vaccine, which is why it has to be stored at these crazy cold temperatures to preserve it, because there is no preservative. So for people that are worried about additives and preservatives and things like that, there just aren't any in this vaccine. And that's why once they open a vial and they use the vial, they can't like leave it sitting around. It's done.
Diane, if you're not unmuted, unmute and let's hear your question.
Okay, Katie, my question is, one of your slides, you talked about who could not get the vaccine, and I wasn't sure if you had an autoimmune disease, lupus, or pregnant, that you are not able to get the vaccine. Is that correct?
Sure. So it's just those people were not included in the studies. So if you're in one of those groups, that's going to be one of these things where you have to talk to your doctor, and you, the doctor yourself, will need to figure out whether you think it's safe. For most people, let's say somebody with lupus is a good example. If they're maintained and stable and generally doing okay, and they're not in sort of a crisis mode with the lupus or having a flare, they probably can get the vaccine quite safely. And I wouldn't be surprised if their doctor would say, you're okay to get the vaccine. That's kind of what they're telling pregnant is, as long as everything's normal with your pregnancy and you're feeling okay, the vaccine is probably safe. Where it's kind of a gray area is those people weren't in the studies. And so we'll learn about those people as some of them get vaccinated and they get followed over time. It does become a harder thing, right, for your doctor and the patient to think about and talk it over as to whether or not they feel comfortable getting the vaccine. They're not prohibited, though, in any way. They just weren't in the studies.
Thank you.
Okay, we have a question from Erwin. He wants to know if there's a difference between the two vaccine manufacturers and if there is one that's superior, and if they with the difference in generating antibodies.
Right. It does not appear that there's any meaningful difference whatsoever in the effectiveness or the safety of these two vaccines.